everybody, in this video we're going to talk about how to factor something with two terms that's in the form a squared minus b squared using the difference of squares formula. Okay, so just looking at our flowchart, remember always take out a greatest common factor if possible. If it has two terms, then next we're going to add one more thing to our list, this difference of squares formula. Okay, so in the past, when we have weird situations, for example, x squared minus 25, it's missing the b term, so sometimes we would write it as x squared plus 0x minus 25. We would do our t-chart, we would find that negative 5 and 5 work, we'd go through our grouping process, and we would eventually get x minus 5 times x plus 5. That totally works, but if we notice this x squared minus 25 form, there's actually a formula that's going to give us right to the answer, and we're going to skip all of this part. So when we're looking, it's called difference of squares formula, make sure you write this down. So a squared minus b squared is equal to a plus b times a minus b. So let's talk about what that means. So both of these have to be perfect squares. So a squared is a times a. A perfect square is just the same number or variable multiplied by itself. So hence the squared. So if this is a perfect square and this is a perfect square, that's check one. Check number two is that this has to be a subtraction. If there's a plus, we cannot use this formula, so be very careful. So in the end, we're looking for perfect squares and we're looking for this minus here. So let's bring back up this example. X squared, is that a perfect square? Can I multiply the same thing by itself to get x squared? Yeah, x times x is x squared, so that's my a term. So a is gonna be x, and then I have a subtraction, great. 25, is that a perfect square? Yeah, 5 times 5 gives me 25, so that's my b term, and now this is really nice. A plus b, well, x plus 5, and then a minus b, x minus 5, that is your answer. So if you have two perfect squares, it's really easy, you're just plugging it into this formula. Okay, let's look at another more tricky example. So we have two terms. I cannot divide out a greatest common factor, so now I'm going to see if I can use my difference of squares formula. So 49, what times what gives me 49? Well, 7 times 7. And then I'm looking at x to the 6. Now be careful when you have exponents. Remember the rule, when you're multiplying exponents, really you're adding the exponents together. So I'm asking myself, hey, what two numbers could add together to give me 6? Well, 3 plus 3. So that's really tricky. When you have exponents, just remember you're finding two of the same numbers that add to 6. Okay, cool. So I have my a term, 7x cubed. 9 is 3 times 3, and y squared is y times y. So my b value is 3y. Then I put them all together, add them together, subtract them together. So there's my final answer. Okay. Really quickly, if you ever see two perfect squares together and it has a plus, that is going to automatically be prime, assuming that you can't factor out a greatest common factor. So if you see this and it had a plus in between it, you're going to stop and say prime. All right, lastly before you go, so when we're looking at perfect squares, it is nice to kind of have them memorized. So I put this chart here. If you want to look over it, you're looking for numbers like 9, 16, 25, 36, 144. Those are going to help you because you're going to be able to identify them easier, and it might save you some time. So if you need to write that down, do so. If y'all have questions, come find me. If not, I'll see y'all in the next one.